Today we're still looking at theoretical probability, although the questions might be a little bit more challenging than what we saw yesterday. And we're also adding something called complement. So the complement of an event is the chance that it will not occur. And if you take a look at this symbol here, the apostrophe is what symbolizes not. So I used E for event, and then the apostrophe means that that event will not occur. Starting off with a reminder of yesterday, we started off with rolling a die. What's the chance that we roll an even number? Well, 2, 4, and 6 are even, so there's 3 chances of landing on an even out of 6 possible numbers on a die. Simplifying by dividing them each by 3, we get 1 out of 2. So a 1/2 chance, converting that to a decimal, 1 divided by 2 gives us 0.5. And multiplying that by 100, we get a 50% chance. Second question, what's the chance that we roll a number less than 4? So that does not include 4. So that would be the numbers 1, 2, 3. So there's 3 chances that we get a number less than 4. Since this is the same probability we got the first time, it equals a 0.5 as a decimal, as well as 50% when we multiply that by 100. For example 2, we're using a deck of cards. Now what I've discovered is that over the years, as computer games have become more and more popular, students are playing with physical cards less and less and don't entirely know what's in a deck of cards. So I posted what's in a deck of cards to Schoology. I'm going to show you where to find that next. All right, so in your Algebra 1 Schoology page, we are in Unit 7 Probability, so we're going to click in there. And then right under the assignment sheet that tells us what we're doing each day, there is a PDF of a deck of cards. So we're going to take a look at that. So in the deck of cards, there are 4 suits. The 4 different suits are clubs, spades, which are both black, and then hearts and diamonds are red. So as you can see, half of our deck is black and half of our deck is red. Within each suit, you can see they have the exact same cards in each suit. Ace through 10 and Jack, Queen, King. So we've got number cards. The numbers are 2 through 10. Ace is not considered a number. A is a letter. And then we have what are called face cards. That's the Jack, Queen, and King because, funny enough, they have faces on them. So this PDF is here for you to use not only for your assignments, but also if there are any card questions on your test or quiz. We don't want you to get it wrong because of your knowledge of a deck of cards versus your knowledge of probability. So our first question is, what's the chance that in a standard deck of cards, which is what I just showed you, we pull a 5 out of the deck? Well, as a reminder, there are 4 5s, the 5 of clubs, the 5 of spades, the 5 of hearts, and the 5 of diamonds. And one thing I failed to mention, there are 52 cards total in the deck. This does simplify. 4 over 52 simplifies to 1 over 13. So here's a quick way to remember some of the multiplication facts that are maybe outside of your normal multiplication chart. There are 4 suits in a deck of cards and 13 cards in each suit. So 4 times 13 gives us the 52 total cards in the deck. We're going to use that a lot with our deck of cards. 1 divided by 13 is not an exact number. I'm rounding to 3 decimal places and I got about 0.077. So when I multiply that by 100, I get approximately 7.7%. My second question is, what's the chance that I pull not only a red card, but also a face card? So the card I pull out of the deck has to be red and have a face on it. So we have the Jack, Queen, King of Hearts, and the Jack, Queen, King of Diamonds, a total of 6 cards that are red and face card out of the 52 cards in the deck. This one simplifies as well. I can divide them each by 2 and I get 3 out of 26. This one also does not divide nicely. I got approximately 0.115. So multiplying that by 100, it would be about an 11.5% chance of drawing a red face card. And this last one is getting into complements. So I'm going to write this with the complement notation as well. So this is asking what's the chance that it is not a club. So C for club, and then that apostrophe means not. Well, there are 13 cards in the deck that are clubs. So there are 39 cards in the deck that are not. You can either do 52 minus 13 to get 39, or there are 13 cards in each of the other three suits. So 3 times 13 gives us the 39 as well. This does simplify. I can divide each of those numbers by 13 and I get 3 out of 4. Hopefully you know how to divide 3/4. Think quarters. 3/4 is 75 cents or 75%. And the last one, we're going to look at some more complements. Our first example, if there's a 45% chance that it does rain, what's the chance that it will not rain? So I have this notation written here for you again, so you can get used to that. So probability of not rain, that's what it means inside the parentheses here. Well, there's a 100% chance that it will do something. So we can take that 100% minus the 45% chance that it will rain, and that gives us a 55% chance that it will not rain. Converting that back to a decimal, we divide by 100, which gives us 0.55. And then percents are numbers that we compare out of 100. So 55 out of 100, which does simplify. They can both be divided by 5, and we get 11 out of 20. And our last question, there's a 90% chance that you get a quiz on Friday. What is the chance that you do not have a quiz? Well, same thing. There's a 100% chance that something will happen on Friday, minus that 90% chance of a quiz gives us a 10% chance that we will not be quizzing. Dividing that by 100 to convert to our decimal, I get 0.1 or 0.10, either way. And then we can rewrite that as a fraction by putting it as 10 out of 100, which simplifies to 1/10. Let me know if you have any questions as you're reviewing for your quiz tomorrow, and then have a great weekend after that.